Assalamu alaikum students. In last class we were discussing the recurrent neural networks and LSTM, which is a type of recurrent neural network. As we discussed in class, recurrent neural networks suffer from short-term memory. If input sequence is long, the recurrent neural network cannot handle the long input sequence. So carrying information in long sequence is. Further, we discussed that recurrent neural networks suffer from vanishing gradient problem. Gradients are the values that are used to update the neural network weights. Vanishing gradient problem is when the gradient shrinks as it backpropagates through the time. If gradient value becomes extremely small, it doesn't contribute too much in learning. So with the vanishing gradient problem and exploding gradient, the machines do not learn much. So LSTM's long short-term memory networks are created as the solution to short-term memory. They have internal mechanism called the gates that can regulate the flow of information. So we discussed what is LSTM in last class, and gates, as I told you, gates are the mechanisms that can regulate the flow of information. So basically LSTM, so gates in LSTM are composed of sigmoid neural network layer and point-wise multiplication operations. The gates in LSTM play a very important role. Gates can learn which data sequence is important to keep, or which data sequence does not contain important or distinct information and the data sequence that doesn't contain the important information is discarded. So in this way it can pass the relevant information down along the chain of sequences to make the predictions. An LSTM has three types of gates. An LSTM has basically three types of gates. So the LSTM has three types of gates. These gates are the forget gate, input gate, output gate, and cell state keeps the information or important information from all the timestamp. Cell state is type of repository that keeps the important information from all the timestamps. The information processing in LSTM is basically done in 4 steps. At the first step of LSTM, it is identify that which information is important and which information is not required, which information is needed to keep and which information to throw away. And this decision is made using the sigmoid layer. Here to keep the important information and to discard the unimportant information. The information is taken from the previous timestamp. Timestamp information. This is the information from current timestamp. And then weights are multiplied with them, bias is added, and this whole information is passed to the sigmoid function. This sigmoid function decides which information to keep, which information is important to keep, and which information must be discarded. And this step of deciding important information and discarding of unimportant information is applied at all three gates. Steps 2 basically consist of two things. First is it applied on input activation. This is basically input activation. Previous stamp information and current input is multiplied with the weight, bias is added, and then tan h function is applied on this date. This is done as input activation. Second part of this step 2 is input gate. This is basically input gate. Input gate decides which information to pass to the next step. From the input, which information is to pass to the next step. So at the second step is to decide what new information we are going to store in the cell state. This whole process comprises of the two steps: a sigmoid layer, input gate, and input activation that is obtained by applying the tan h function. So second step decides which information is to be stored in the cell state by using the two things. First one is the input activation and second one is the input gate. Third step. At this step we update the old cell state into the new cell state. For updating the old cell state with the new update, we perform this updation in two steps. These are the results obtained in step 2. This is our input activation. We did in last step input activation, and this is application of input gate. So this was at the previous timestamp is multiplied with the ft, which is forget gate, output of the forget gate. Output of the forget gate is multiplied with the information in the previous timestamp, information in the cell state at the previous timestamp. Information in cell state at previous timestamp. So by combining these two steps, we update the information in the cell state. So third step updates the information in the cell state. Now the fourth step, which is the last step, is to decide what information we are going to output. It depends on the cell state, but it will be a filtered version of information in the cell state. So this step is performed basically in two sub-steps. Here we run sigmoid layer to decide which part of the cell state, basically this is cell state, which part of the cell state we are going to output. We run the sigmoid layer. The cell state is passed to the sigmoid function, which decides which part of the cell state is going to be the output. And then in second sub-step, we pass the cell state through the 10H and then multiply it with the output of this step, this sub-step. So that we may only output the part that we decided to get the output. So these are the 4 steps that are used in implementation of LSTM. Now we'll see the numerical computation of a sequence in LSTM.